Hey everybody, welcome back. So normally I like trumpeting my successes, not my failures, but you can even learn things from complete failures, I guess. So this is going to be a video about my failures with POM or Acetal Delrin filament. For the record, I purchased this roll of filament myself. I am not sponsored in this video in any way. This is Gizmo Dork's POM filament. Now you may remember that I have used Gizmo Dork's polycarbonate filament and I never ever got a successful print with that. So right now my batting average with Gizmo Dork's filaments not doing very well. But hopefully in this case it is not just the filament manufacturer. And I switched to a different polycarbonate. I switched to Polymaker Polylite and I managed to print with that successfully quite a bit, but I have never got a successful print out of the Gizmo Dork's polycarbonate, and I went and bought another roll of Gizmo Dork's filament, and now I'm having the same problem. So let's take a look at what I've tried and what I'm getting. And I'm doing this all leading up to my test where I want to put filament out in the Arizona heat and UV and sun for a month and see which ones survive it the best, just to determine what is the best outdoor filament for a hot, dry climate where you get UV ratings that are almost off the scales. So I have tried temperatures ranging from 240 to 260 with this filament. I have tried bed temperatures ranging from 60 to 100. I'd go higher than 100, but my printer, my enclosed modified Ender 3, if I go to 110, I will start getting failures. So honestly, considering how bad the failures are, I can't imagine going another 10°C in bed temperature is going to make that much of a difference. I've also tried using, and this is in a completely enclosed printer, and I've tried using a heater, in this case an old hair dryer that my wife donated to the cause a number of years ago. I have tried bringing the enclosure up and maintaining it at 70°C during the print, and that has made no real difference either. As far as build surfaces are concerned, I first started out with my favorite old mirror and hairspray. When that didn't work, I tried a build tack sheet that came with the Jaris filament, and a lot of these, I've probably printed 25 of these in the POM, and the reason why you don't see 25 here is because most of them never got past that point. I mean, it's already coming off the, I might as well be printing on Teflon for crying out loud. I tried printing on a piece of 3M 180 grit sandpaper, wouldn't stick. I tried printing on the spring steel PEI sheet, and I've tried using hairspray and glue stick, and it wouldn't stick to that. People said it stuck to paper, so I tried standard old masking tape. I tried, I don't know where it is, there it is. I tried blue painter's tape. Then I saw a video somebody made where he tried this paper drywall tape and it's not sticky at all. I tried that and it wouldn't stick to that. Then I read it sticks to cardboard and wood, so I tried a cardboard bed. And then I tried a piece of this fiber board. I don't have a piece of wood thin enough to go on there and still let me get my nozzle distance set. And as far as nozzle distance is concerned, I've tried everything from really, really close to really, really far away, and you know what, it makes a minor amount of difference. Also, somewhere in here, and I don't see it now, what did I do with it? Can't find it. Anyway, I also tried a sacrificial bed of PLA. I printed a 0.3 layer of PLA on mirror and hairspray, leveled the bed, and printed on top of that. And that's my best result so far. Now, one thing I had to do is I had to lower the bed temperature down from 90 or 100 back down to 60, or the PLA would just let right off the bed. It would just, oh, there it is right there. It just would turn into Swiss cheese. So I got a lot of these, obviously. This is the one that was on cardboard, and you can see what it does, and the desire, the power that it has in the flexing up like a potato chip is incredibly strong. I mean, it was my PLA bed I made, it ripped the PLA right up off the sheet. And you guys, if you've printed on glass and hairspray, you know how much PLA sticks to glass and hairspray. So I got a bunch of these, and there's the one, here's the one on the fiberboard. And you can see it tore the fiberboard completely up off to get it off, but yet it didn't stop it from warping. And here's two of my, and I used black PLA because for the sacrificial bed, because I wanted to be able to tell what was the PLA and what was the Delrin. And as you can see, the Delrin sticks to the PLA really, really, really good. It would be a sacrificial layer. If you wanted it gone, you'd have to sand it off. And here's my most successful one, once again on a sacrificial bed of PLA, but as you can see, it still warped and pulled the PLA up off the bed. I don't really want to get the enclosure up above 70 because there are still some 3D printed parts in that, and I don't want them to go all Swiss cheese on me. I'm not sure, honestly. This is, with this, the closest I've gotten, and this was with the internal temp. This was with the bed at 60, the PLA sacrificial layer, and the internal temperature at 60. I didn't want to go much above 60 again with a PLA bed, or I would lose the structure integrity of the PLA and it would turn into Swiss cheese. This is the best one I've got. I'm obviously not going to go any further at this point because I'm not sure what it really takes to get this stuff to print successfully, or if it can even be done on a printer like an enclosed Ender 3 like I have. I've got an all-metal hot end. I've got an SKR 1.3 board in it. So this is not a stock Ender 3. Now, I also, even though you're not supposed to have to dry POM filament, and I live in the Sonoran Desert, I did dry the filament. And for those of you, and this is not just for this video, if you watch any other of my videos or the ones coming up after this where I do the outdoor test, before you ask me, did you dry your filament, please, and I'll put a link in the cards, go watch my series on do you need to dry your filament. I have extensively tested filaments to see if they need to be dried. Now, I have not done POM or ASA, but I have done just about all the others readily available affordable filaments. So that's where I'm at with this. I'm still going to put these out in the sun. Well, maybe not that one. These out in the sun so we can see what the UV does to them. But also, obviously, I am not going to print the torque test because I can't get a decent enough print to do it. And I'm sick of messing with this. Doing this is a pain in the ass because you got to level a bed, set the nozzle distance, then you got to print the PLA bed, then you got to level the bed and set the nozzle distance again to the PLA bed, then you can do this print, and if it fails, wash, rinse, and repeat. And I did it 3 or 4 times. It sucks. So anyway, that's why when you see my POM filament out in the UV test, which is coming up next, because I'm going to put it out on July 1st, which is 3 days from now, 2-3 days from now. And that's why you're not going to see a torque test with POM in my outdoor testing. Anyway, please put your suggestions, ideas below. If you think there is an easier to print POM filament than Gizmo Dorks, let me know what it is. If you've tried any other type of bed surfaces or any other things that can get this to print without warping, let me know in the comment section. If it is reasonable to do, I would love to try it. Hope you guys had a great weekend. I'll see you in a few days for the summertime UV heat tests. Bye for now.